Welcome to the third video of the series. In this video we are looking at the year 2015. So this was the question for November 2015, and you still have your standard questions. 1.2 is very interesting because we know that when we have simultaneous equations and we are solving for x and y, we need to have two equations. So the fact that we have one in this question raises alarm bells, or at least it should. 1.3 is a nature of root question. It's an interesting question indeed. Starting with the first question, we are given our quadratic equation in standard form. So we factorize, find the factors of 20 that work. 5 and 4 will give you 20, but minus 5 minus 4 will give you minus 9, which is your middle term. So you have x equals to 5 or x equals to 4. The second question is a quadratic formula question. Very important to note that in this particular year, for your quadratic equation, you do not have standard form. So you transpose minus 4 to achieve your standard form. Once you've achieved that, then you can try to move forward. You write your quadratic formula and you substitute your values, and then you get your final answers, and they are correct to 2 decimal places. Third question is an exponential equation. So what you want to do in these types of questions is that at the end you want to have x to power 1 because you are solving for x. So that is x to power 1. So what we do is we raise to the power, which is a multiplicative index of the power that we have for x. So you see we have 5 over 3, so here it's 3 over 5, so that when we multiply these two, we'll get 1. But because this is negative, that's why we also have a negative there, so that we have a positive 1. Very important to note that this power is also applicable to these two, so you should not forget about these two. So you can see that 2 is now raised to the power minus 3 over 5 because you had 2 to power 1. And then x now has power 1, which is what we are looking for. On the left hand side, we have negative and positive, giving us negative. 6 times 3 is 18. 1 times 5 is 5 because 6 is over 1. Now we divide by 2 to the power minus 3 over 5 on both sides, leaving x to power 1 on its own. Because we are dividing and these two numbers, so you have 2 on the numerator and 2 in the denominator, so these two powers have the same base, so we take one base and we subtract the exponents, and then you simplify it to x equal to 1 over 8. Then you have a quadratic inequality question. It is in standard form because it means c is 0. So we factorize by taking out the common factor. The critical values are x equals to 0 and x equal to minus 7. The question says less than. So if you see here, it's less than. So therefore, if it's less than, It means we are looking at the section of the graph that is underground. And that section starts from -7 to 0. So you have -7 and you have 0, and there is no break in the interval. So this is how you write it. Notice that both arrows are facing the left hand side, because all the time numbers on the right hand side will always be bigger than numbers on the left hand side in a number line. 1.1.4, we have set equation. The third is already isolated. We must square both sides to get rid of the square roots. So you have 2 minus x on the left hand side, and you have x minus 2 times x minus 2 on the right. So we simplify further, and then we transpose x. So now it's positive. 2, which was positive, is now negative, and we achieve our standard form. Once we have our standard form, we can factorize, and we can find the values of x. Because it's a set equation, it means the original equation will only have one valid value or one valid solution. So you need to check both. And in this case, x equals to 1 is the value which is invalid, or which is not the solution. We move on to simultaneous equation, and I did mention briefly before that this is a special question. So we are asked to solve for x and y, but the problem is we have only one equation, and that just seems like something is off. We are supposed to have two equations, but there's a trick. And it's actually something very, very simple and straightforward once you realize it. So if you look at this equation, it is telling us that 3x minus y all squared plus x minus 5 all squared is equal to 0. But how come? How is that possible? The square of any number is always positive or 0. So for the sum of two squares to be 0, both squares must be 0. Because if you had 1 on either square, then your answer will be 2, for instance. But the fact that the answer is 0 when you add these two squares, it tells us that each of these squares is equal to 0. And that is how you generate your two equations. So you have x minus 5 all squared equals to 0 as your first, and 3x minus y all squared equals to 0 as your second. So you start with the simpler one. So if you put square roots, then you have x minus 5 equal to 0, which means x equals to 5. And once you have x equals to 5, you can then continue to the equation on the left hand side. You substitute the value of x, and you get your value of y to be 15. Very interesting question. The process of finding the values of x and y are very simple, but the trick was realizing that when you add two squares, the only way that they will give you 0 is if both of them were 0. The special question in this paper was a nature of root question. The question says, for which value of k will the equation x squared plus x equal to k have no real root? Now, for no real root or non-real root, the discriminant should be less than 0. So the discriminant, what is a discriminant? it is b squared minus 4ac, which is what we find under the square root in our quadratic formula. So that is our discriminant. But in order to find the value of our discriminant, we need to go back to what we were given, which is x squared plus x equals to k. It's a quadratic equation, so we must get it to standard form. So once it's in standard form, we now can see that a is 1, the coefficient of x squared, b is 1, the coefficient of x, and c is equal to minus k, which is the constant. Now we substitute in the discriminant so that we get 1 squared minus 4 times 1 times minus k less than 0. So 1 squared is 1, minus 4 times 1 is minus 4, times negative k is positive 4k, and we simplify, we transpose 1, it becomes minus 1, we divide by 4, so k should be less than minus 1 over 4. So that is how you approach this question. So if there's a part you did not follow properly, I would advise you to just go back to the start of this section and just try and follow. I try to simplify the process as much as I can.